Hey, we're back at our local trout stream today. We're going to be collecting some measurements on the stream, actually doing some math and a little bit of physics here. Once again, our goal is to help quantify as many aspects of this stream as we can. One of the tough things about environmental studies, looking at wildlife, is trying to collect as much quantitative data, not qualitative data. All right, we know just from looking at this that it's a pretty healthy looking stream. Okay, it's got all the features we look for as far as the life that's living inside of it. It seems to be not a bunch of erosion and whatnot, and so we want to quantify a lot of that to actually get a measurement so we can test other streams against that. Today we're going to be calculating our flow rate, so we're going to need our velocity, we're going to need our volume of water that's moving over this particular stretch of stream. We're here, right behind me is where our leaf pack net was, and so we're going to be doing some calculations using some things you probably have at home. Okay, so once again, our goal here is we want to find out how much water is moving through this stream every minute. Okay, that's our goal, our flow rate. We want to know, is it thousands of gallons of water per minute rushing downstream, or is it just a little bit slowly working its way down? That's all information that tells us a lot about our ecosystem. What we're going to need here to set us up is I have a tape measure measured out. We're going to work in the metric system because this is science. That's what we use, and it's a lot easier. And I've made it easy on us. We have measured out 10 meters along the stream bank. So from the start of my measuring tape to the end is 10 meters. All right. Next up, you're going to need a timer and an object that floats. I'm going to use my watch and the timer on my phone, and I've also brought a tennis ball. What we're going to do over the course of those 10 meters, we're going to see how long it takes an object to float downstream for those 10 meters. All right. What that does is that tells us the speed at which the water, at least on the surface, is operating at. Okay. Okay, we're going to be measuring stream velocity. It works best if you have two people. I don't, so I'm going to try to rely on my speed. I'm going to set our tennis ball down here at the beginning of our measuring tape, and I'm going to run downstream and grab it after it's gone 10 meters. Based on our speed, I think we'll be okay here. All right. The biggest question is going to be if I drop my phone or not. All right, so tennis ball in the stream. Run on down. There she comes. I'm gonna try not to fall. It's cold. Okay, good timing. And bingo. One tennis ball, one trial. We'll get a time on that and get it to you. Okay, the last measurements that we need to take here to calculate our water output or flow rate of the stream is we need to get some kind of depth measurement going across. All right, you've all seen streams before. I'm not sure how well you can see one right now, but the depth varies quite a bit based on what part of the stream that you're in. We'll notice here I have a big rock that's pretty shallow, do a groove there that's pretty deep. So we're going to take an average going across. First thing we have to do is figure out our distance. Okay, our distance across. And if you're looking, I got 5 meters straight across. All right, 5 meters straight across. That's gonna be a really nice number. I'm gonna be able to take a measurement every meter, and we're gonna be able to use that as an average. My tape measure's taking off on me there. Okay, we're gonna be able to use that as an average moving forward. All right. Okay, back in the stream. I got my meter stick. We're going across. Our first measurement here, like I said, we're going for about 1 every meter. And boy, I picked a turbulent part of the stream. We go in, and our first measurement is it's 40 centimeters deep. Moving on to a second one at 2 feet. We have a depth of 48 centimeters. You see that? Moving on to our third meter in. That's a depth of 36 centimeters. And then our fourth measurement is, it gets real shallow over here, and we're looking at a depth of 11 centimeters. Okay, so there's 4 measurements going across. We're going to take the average of that. That's the average depth multiplied by the width, and we're going to be able to calculate how much water exactly is flowing through this bad boy every minute. All right, hoping you guys get a chance to get out and do this yourself. Maybe pick a nicer day than I did, but it's a cool way to go out and explore our local ecosystems. It's always fun to mess around in the stream and see what you can find there, and all that stuff. Okay, so good luck. Let me know if you got questions, and then get out and enjoy nature, guys. Now that we have all of our data collected, we need to do a little bit of math in order to do our final calculation as far as how much water is moving down this stream every minute. Okay. Hey, what you're going to want to do is do that first part first that we collected the data on as far as the velocity goes. So we need to figure out our average velocity. All right. We're going to take our average distance. For us, I did the exact same distance every time, 10 meters. All right, so 10 meters is our average distance. And then that average time. You have to figure out the average time. Divide that distance, divide by that time, and we're going to get that average velocity. All right, so we have average velocity. That's already figured out. We need to take that times our width of the stream and our average depth. Okay, so our average velocity that we got up here times however wide our stream measurement was, and then the average of all those depths that we took going across the stream. If you did it with me, we were 5 meters across, and our average depth, you're going to have to calculate, but we took 4 different measurements. So we're going to take the average of those. All right. Doing that math, we should end up getting a flow rate out of all of that. All right. Good luck with that.